Roll 'em. Good afternoon, chemistry students. Mr. Bennett here in the backyard lab once again to talk more about solutions. This time we're going to be talking about solubility curves. We're just going to go over the basics today. This shouldn't take too long. What I'd like you to do is try to jot down some notes, and obviously that should be pretty easy since you can pause. And if you have any questions, send me an email. And so here we go. First of all, I want you to recall what solubility means. That just means the amount that can be dissolved. So obviously there's a limit to how much solute can be dissolved in a solvent, so how much salt can be dissolved in water. So if we know how much salt we can dissolve in there, that would be the solubility of that. So solubility is the amount that can be dissolved. Okay, and then we talked about, I think we may have talked about this last time, these three words: saturated, unsaturated, and supersaturated. Saturated basically means it's full. The solution is full, it can't hold anymore. So we'll just call it that. Can't hold anymore. So with this glass, let's say this could not hold any more salt and it's full, it would be a saturated salt solution, sodium chloride solution. Unsaturated means it's not full. So unsaturated means it could hold more. So for example, here's some water. If I put that much salt in there, obviously it can hold more, so it's unsaturated. This one might be saturated, I'm not sure. And then there's another situation where called supersaturated. We're really going to go into that more, but that's when a special situation when a solution can hold more than it can hold, which doesn't make any sense, but we'll just say it can hold more, than it should, whatever that means. We'll define that later, but okay. Now I want to take a look at this picture here, which shows the solubility of sugar in water. And let's take a look. Anytime you look at a graph, you should look at the axes. This axis is the temperature, which goes from freezing point of water, 0, to a boiling point of water. These are Celsius temperatures. Then this axis is grams of sugar in 100 milliliters of water, which goes from 0 to 500. So this just shows how much sugar can be dissolved in 100 milliliters of water, depending on the temperature. So that varies with temperature. And if I was in class right now, I'd say, well, what's the trend here? How does temperature affect the amount of sugar that can dissolve? Well, you can see the slope goes up. So let's take 20 degrees. So at 20 degrees, how much sugar could be dissolved in 100 milliliters of water? Well, how would you do that? Well, you could go right to 20 degrees on this graph. You can go until it hits the solubility curve, the blue curve. Then you can come on over here, and that's roughly 200 grams. So at 20 degrees Celsius, about 200 grams of sugar would dissolve in 100 mLs of H2O. Okay, what about at 60 degrees? 60 degrees. So if we go to 60, and you just go. Well, that's roughly 300 grams of sugar. So at 60 degrees, about 300 grams of sugar could be dissolved in 100 milliliters of water. Any questions on that? Okay. So we could conclude from this solubility curve of sugar that the warmer the water, the more sugar dissolves in the water, right? And you probably know that from experience anyway. Warmer water tends to dissolve things better in general. Not always the case, but with most solids it is. So one thing I also want you to notice on this curve here, if you're anywhere along that curve itself, it's saturated. 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 Anywhere along that curve is saturated. Below the curve, anywhere below the curve down here would be unsaturated. And above the curve would be supersaturated. So above the curve is supersaturated, right on the curve is saturated, below the curve is unsaturated. Might not be a bad idea for you to make a copy of this graph and label that in your notes. I would do that. So now we're going to switch to some more solubility curves. This one's not sugar now. This one is many different compounds. Sodium nitrate, potassium iodide, sodium sulfate, ammonia, hydrochloric acid, ammonium chloride, and so on. And notice that the dotted lines are gases, and the solid lines, the solid curves, they're not really lines, they're curves, are solids, okay? So, and remember the axes, just like in the other graph, temperature and grams of solute, and the other one it was grams of sugar, but this one it's grams of whatever it is per 100 grams or 100 milliliters of water, okay? And so for solids, you might notice all the solids have a what? An upward slope. What about all the gases? Downward slope. What does that mean? Well, it means for solids, warm water dissolves more. If it's a solid, warm water but if it's a gas, cold water dissolves more. For gases, cold water dissolves more. That may be kind of unexpected, but we'll go into that more later. You probably can relate to that with soda pop, but we'll talk more about that later. Now let's just take a couple of examples here, and just like we did in that other one, let's take a look at NaNO3. NaNO3, which is right here. It's this curve, and that's sodium nitrate. And what if you wanted to know how much NaNO3 could be dissolved at 40 degrees Celsius? So we go to 40 degrees Celsius right here, and then you just draw a dotted line up until you hit the NaNO3 graph right about here, and then come on over here. So that's looks like it's a little more than 100 grams. So at, what was the temperature again? 40 degrees Celsius, you could dissolve about 100 grams of sodium nitrate, NaNO3. Okay, let's do one other example. We'll take NH4Cl, that's ammonium chloride. So let's find that one. Ammonium chloride is here. This one? No, that's sodium chloride. Where's ammonium chloride? Ammonium chloride There it is, right here. Ammonium chloride, it's this one here. And let's take a look at that one at 90 degrees. So at 90 degrees Celsius, how much ammonium chloride could you dissolve in the water at that high temperature? So 90 degrees is here. You just go doot, doot, doot. So you hit ammonium chloride. Come on, pen it. Get it right. Right about here. And then you come on over this way. Looks like that's about 70. Okay? So about 70 grams of ammonium chloride could be dissolved in 100 milliliters of water at that temperature. Obviously, if you cooled the water, it would be less. If you cooled the water in the sodium nitrate example, you can dissolve less. Okay? And that is really all I wanted to cover today. We'll get into more details the next time. Okay?